more into this. Um, let's go ahead and start then and talk about the history of aerial photography. And we're going back, about 150 years ago? Maybe what? No, I guess almost 200 years ago now, mid 19th century, to France. And it was a guy named Nadar. And here's a picture of an illustration of him here, right? But he was a photographer and he really wanted to get some pictures from the air. First person that, I mean, around this time where any of this kind of equipment was available, I'm sure he wasn't the, I'm not sure that he was necessarily the first person that thought of doing something like this, but he was the first person that actually pulled this off. So, for all intents and purposes, the first aerial picture ever captured, at least on record, is from Nadar, and it's from his hot air balloon flying over Paris. Okay, um, balloon. Okay, so from that point on, because there actually wasn't airplanes yet in the mid 1800s, so we kind of had this renaissance or this revolution of ideology of, oh, hey, aerial photography, this can be actually useful and artistic and more than just a hobby thing. And so more and more people tried to get into it, and there were various attempts at some successful, some not, but at accomplishing something like this. Because a hot air balloon, I mean, for all things back then, technology-wise, was probably the best use, probably the best source to get up in the air and take some pictures. But let's be honest, if anyone's ever been in one, it's not the most dependable, especially 100, 200 years ago. So people would attach them to kites or other things like large pigeons or other birds. So miniature cameras attached to a bird like this. I mean, people became resourceful and did what they had to do back in those times. But very interesting things were happening. Now, when airplanes actually came around and the Wright brothers, invented I guess you could say, were the pioneers of aviation from this perspective. They were the first ones to take a camera and plop it out and take some aerial pictures. So this is in the early 1900s, kind of at the same exact time when aviation became, was taking off, right? The dawn of aerial photography was pretty lock in step with that. Now, these things weren't really, even airplanes, right? They weren't really on a commercial level per se yet. It's not something like, even today, today you go to an airport and you can catch any flight anywhere you want to go in the world, basically, and be there within a day. That's not how it was. So airplanes, in this context, and aerial photography, in terms of use case, really became something that was found to be advantageous during World War I. And so the Allies, in particular, were using aerial photos to scout and like reconnaissance missions of the enemy's base and forts and trenches and things like this. So that was the first time that aerial photography had a real place in the history of in history as something that could be used over and over again for a particular purpose. So aerial pictures like this, or aerial pictures where the camera was pointed straight down, and guess what that actual name is? Technical term of pointing a camera straight down is called nadir. I think it comes from nadar. I'm pretty sure it comes from nadar, but nadir with an IR at the end. Anyways, pointing the camera at a nadir position, so like this, would enable the military to take pictures and kind of mosaic them or stitch them together and create these large, like, mosaic aerial photos, which essentially were the maps that were used to scout the enemy's territories. So this was very, very advantageous for the Allies, like I said, and this kind of military operation continued as far as what aerial photography, where it started from, and continued to be. It really continued this way even up through World War II. Okay, technology didn't really advance dramatically, not nearly at the rates things do nowadays. But the move to commercial did not happen, or civilian did not happen until after World War II. And then we got to a place where aerial photography certainly would be kind of used more for like this surveying and mapping, not for finding enemies in a wartime, but let's say mapping a new interchange on a highway, or mapping an environmental project where there was a large field of some type that needed to be mapped. And aerial photos came in very handy for that type of purpose. And even to today, those are the kind of things, as we'll see, especially in part 2 class. But as I have a few examples here to talk about, and I'm happy to discuss further with you guys, that drones can be used for. Anyways, now, speaking of drones, since this is a drone class, the drones that we're going to use in this class, and the in the context of, are they used for the military or whatnot? No, we're going to actually use. I wrote commercial here a couple of times. I meant to say consumer. Okay, we're talking about consumer drones, something that you or I could purchase at any point in time, e-commerce, retail, whatever it is, and use it for our purposes. Now, what this class is going to teach you is how you can use it, when and where. But what I'm getting at here is we had to go a long way in time before consumer drones really became, something to mainstream. And we're talking now into the early 2000s, really about 2008, 9, 10, around there, was when, drones that we would think of, when we think of except a military type drone, but drones that we might think of, that you might see in a commercial or something like this. This was starting to come around more so in this time frame. Okay. Maybe it's helpful if I do it like this. Hi. All right. So yeah, drone. When we say drone, let's move on to the use cases. How they're used, right? Are they military? Sure, absolutely, right? They certainly are. Like you've heard the Predator or the Raptor or the Global Hawk. Those are just some of the common names. But there's dozens and dozens of these types of military drones. And military drones, when we speak of military drones, we're talking even up to the size of like a 737 jet, right? That you would board a commercial airline. Some of them are that size, okay? Now, being a drone, there's just no pilot and there's no passengers. So there's no people on board. But they could still be upwards of that type of size for missions like flying across the world and scouting terrorists, or executing, hate to say it, but the reality is there's certainly a drone warfare out there. And, it's definitely like a taboo or controversial thing for some people to discuss. And it's also a thing. And so this is what, especially, right from the get-go here in this lesson, it also has this negative connotation in that context where people don't know anything else. People don't know about drone in any other way, and they only think of it as this military killing machine or spying machine, right? And the thing is, for military uses, I mean, they've certainly got their place, but the word drone is more, or can be uh, used in examples other than just the military. So, like for example, the consumer market, right? And there are some consumer drones. Now, I'm kind of speaking off the cuff here as I'm thinking about this, but very, very, very few consumer drones that are, I would say, smaller than or bigger than, right? So when we think of military, we think of like jet size. When we think of consumer, we think of, let's put it in the context of uh, no bigger than the size of a small bedroom, or maybe a small car. Okay, now for 99.9% of the consumer drone market, that's going to be too big, and it's going to be very cumbersome and not inexpensive. Something with that size for the particular use cases that consumers might think of. Um, when I'm saying consumer, and really I could add slash professional to that. Um, but when I speak in this context here, and I'm looking at this graphic here, okay, with these various sizes of drones in them, okay, these drones here are about from here to here, right? And I know it's hard to gauge what I'm saying with a screen like this, but I'm thinking within about, I don't know, 3 feet across to maybe a foot across, or somewhere within that range, okay? This is where 99% of the consumer drone market will be found, that type of drone, okay? And so it's what we're going to use in this class. It's what we're going to more or less kind of for the remainder of this lesson and talking about different types of photography, etc. It's from consumer type drone, okay? And so, yeah, I wanted to make the distinction of where those are between military versus consumer. Now, military could use consumer types of drones as well. The difference is these types of drones only fly for maybe a half hour at the max, in most examples, and not nearly as high, not tens of thousands of feet. So they wouldn't be the best for spying without being caught, or other examples, right? But maybe some short mission from location to location, or from 1 mile to another mile, or a few yards to a few hundred yards to a few hundred other yards. Sure, that could be used in military uses. But when I'm thinking of them, I say of consumer drone, I'm not thinking military. I'm thinking of civilian application. Okay, and then the next group would be the toys. And the lines do get a little blurred between consumer and toy, but and you're going to find out actually in this class, because we will use what are technically classified as toy drones in the beginning. That's what I'm intending us to do. But anyways, other than having fun, if they have a camera, you can at least take a picture with them. There won't be many, as I'm going to mention here momentarily, there won't be many use cases that we can actually provide, let's say, consumer services or professional type of services or professional activities with. They're basically just to have fun, right? Take pictures if they have cameras on them. But they are fun anyways. So that's why they're cool. That's why they're a toy in the first place. Moving on. Okay. So, wow. You may have thought of these, or have even more to add to this list. I filled out what I could fit on a slide, and I'm sure I'll think of even more later on during the week. But let's just kind of bring up a few. When someone says, "Hey, why are you taking a drone class?" You can say, "Hey, well, I'm interested in using it for so-and-so ideas, right? Or so-and-so use cases. Um, Drone racing, that's, I guess I could call it a legitimate sport. I don't know if I'd say sport in my classification of it would be, but there is a special talent to it. And it does air on ESPN sometimes. So, whatever your designation of what qualifies as a sport may be, um, I guess it's no better than cornhole champion or something like that, right? Anyways, drone racing, not necessarily something I'm into. I've seen it a handful of times, and it's pretty cool to watch, in particular when you see it in person. But there are leagues for this, and there are, um, you know, if you're really good, you can actually, I guess, make some money at it. I've never explored it, so I couldn't tell you, how much a drone racer makes, or what are the requirements to become a drone racer, etc. That was never my purposes for using drones, but I know they're popular. Okay, so anyways, we did talk about military already. There is the use case of delivery drones. Um, Yeah, and this is something that's kind of been around a while, and is very very slowly um, coming around. You know, as rapidly as rapid of a revolution, or as rapidly as the drone industry evolves, the delivery use case is on a much slower, spectrum, or a much slower scale in terms of its availability. In some countries, it's more prevalent than the United States, but because we have, and you will definitely learn about this in this course, but because we have the Federal Aviation Administration, which is a pretty strict, for good reason, um, you know, organization within the government, delivery drones just aren't really a thing yet. It's not something that, as I say this in the fall of 20, um, you can really count on. But, and this is timely, there's an article here that I grabbed from the New York Times from late August, where Amazon has been lobbying for this for years and years and years, about 7 years or so. They wanted to have this thing called Amazon Prime Air, where in certain locations you could order your package and have it delivered within a couple hours, not a couple days, a couple hours, right? And so via drone, right? But they ran into a lot of hurdles when it came to the FAA restrictions. Um, but with that being said, check out the article because they just got some approvals. I'm not saying it's going to be like tomorrow and Amazon's going to be able to deliver drone packages to your house via drone, but it's coming. This is a big deal in the context of delivery drone. Once Amazon gets it, it's going to be a game changer. Okay. Yeah, movies and TV and films, certainly. When we look at the consumer market, the film industry is by far the number one use case. Okay. Um, and search and rescue for like law enforcement and public safety professionals. So here's an example I posted here, this little image. This would be an infrared picture, nighttime picture. So um, a lot of search and rescue examples are out there. If you search the internet and look for those, there's stories where missing kid in the woods and found by local authorities via a infrared drone. Pretty cool stuff. Um, Construction monitoring, seeing how things progress over time. Like I said, kind of like the interstate project, or building developments, things like this. General mapping, right? So we take the reconnaissance from World War One. The same exact kind of principle can be applied to, 21st century, and mapping. That's what part two class is all about, right? Environmental use cases. like I said, maybe it's an invasive species or some type of habitat mapping. Could be, I don't know, who knows? I put many more because I don't have all the answers. I can't tell you this is every single use case that's going to be out there, because what is really exciting about this industry, and um, something that I think is um, keeps me engaged, is that there continues to be continues to be new examples of how people are using drones. So I think that's really neat. All right, now the types of drones. Okay, the types of consumer drones. Let's go over really the big three. The big three, and the quadcopter being the most ubiquitous one of all. So that's like the big one, and that would be in the range of 90% of the consumer industry in general. Not all of them are Phantom drones, but most of the DJI line, and most of at least any other drone manufacturers has some type of quadcopter in their portfolio. So quad meaning four uh, motors, okay, and copter meaning that it will ascend and descend, okay, just like a helicopter. So the motors spin and takes off, and then they actually on opposite sides um, spin in different directions, okay, and via changes of voltage to whichever motor is being or whichever direction is being um, let me back up. So changes in direction, how it can kind of fly horizontally, would be by changing various voltage from motor to motor to motor. Okay, um, and so yeah, quadcopters have this um, very kind of universal fit in terms of they're easy to use, and when the consumer market was, I would say, starting up a number of years ago, uh, the quadcopter, based on these examples I'm talking about, kind of won out as a design, uh, the design winner, and became really the standard when it came to drone copter types. Okay, so here, let me show this to you guys. Okay, here's one from our fleet that you will get to fly. Stop my share. Okay, there we are. So this is called the, whoops, I don't want to hide that. There's the make called DJI, and this particular model is called the Spark. But this is a quadcopter drone. Okay, so 1, 2, 3, 4 rotors. A copter being it has propellers, right? And so, like I said, these two here and here would turn in the same direction, and then the opposites would turn in the opposite directions. That's how it works. Okay, copter meaning it goes up, goes down, side to side, like that. Okay, that would be a great example of a consumer copter drone. Okay, next, the examples I have also here that are additional types of copters. There's something called a hex, which would have, instead of four blades, we're talking 6 blades now. Okay, so six motors. Actually, a better way to say that. But 6 motors, or an octo, 8 motors. Okay. Now, why would you even need to go beyond the 4? Well, when you get into larger payload type of use cases, so very heavy types of sensors that are going to be on board the drone to be lifted and to be used. And those heavy sensors could be if it's in the film industry, maybe a high-end HD filming camera, right? That could weigh, I don't know, 10, 20, 30 pounds, something like this, right? But something like that. Or something like what's called a LiDAR system, which is a laser ranging type of sensor for surveying, okay? Those sensors weigh in that type of 20-pound, at least, range. Your little your little Spark drone is not going to be able to lift something like that. So you got to get more motors, and you got to have more juice to be able to boost those types of payloads. Okay, those are the times when you need something like that. Okay, moving on. That kind of explains the basics of the copters. The next popular type is called a fixed wing here. Okay, so fixed wings, right? They essentially have the physical makeup of an airplane. Okay, and fixed meaning that the wings, in most cases, most manufacturers, the wings do not move at all. So whether it's kind of how it's packaged as one like one continuous piece, or it's a body with wings that attach to the body and then becomes one piece. Either way, when it's flying, it's one continuous wing that flies. And so these are great for flying much longer types of missions, or longer flight times are needed, because instead of a copter that's always using all of its energy at all the motors at all times just to stay ascended, wings, aerodynamically, they kind of glide through the air. And so they can use a lot less batteries, and they could fly faster, and they could, essentially that's how they can fly longer. The best use cases for fixed wings are mapping type missions, mapping type jobs, okay? Because the camera in almost every example is going to be pointed straight down type, because where else can it go? It can't actually move at all, and I'll talk about that in a minute. But in those wing types, it's going to sit somewhere on the belly, and it's going to be pointed in a downward position. And so in those cases, when you're pointed downward and you're at that nadir position, you're going to be using, you're going to be wanting to do that for a mapping type of mission, okay? So those are the types of consumer drones. Let's move on. All right, let's talk about how copters work. If I broke down a copter and took it apart, this is what it would look like. Okay, the main components that are important. Let me be kind of crystal clear about something. This class, not just because we don't have the obvious face-to-face interactions to do so, but it's not really what my specialty is. But this class will not be a build the drone yourself type of class. It's just not what we're going to do here. Okay, everything that I have is pre-packaged and kind of sold turnkey. Okay, but just to understand what's going on, because you do need to know a lot of this terminology. It's important, if I'm throwing these things out to you guys, that you need to know specifically what these things are and what they're called. So as we look at this, okay, there's a lot going on. Let me kind of work my way through this, okay? Let's see, let's start over here. Hope you guys can see my little mouse pointer. So 2.4, I'm just gonna go from right to left. 2.4 gigahertz antenna. Okay, so the antenna would be hooked up to hooked up to this thing here called the receiver, and that is going to communicate back with a radio control, okay? Something that the pilot has at his disposal. So as the pilot is moving the controller around to navigate the drone, the information is being sent via the frequency, 2.4 frequency, to this receiver, okay? That receiver goes, then sends that message to this thing here called the flight controller, okay? And really, if we look at where all these different wires are going, this flight controller is the hub of the drone. It's like the brain of the drone, okay? So that's the main computer for the drone. Not just receiving the signals, but it also receives signals from a GPS module attached to it if it has that aboard. Everything that we have in our fleet, well, I shouldn't say everything because the Tello drones don't, those are more toys. But once you move on from the toy type of drone, you're going to end up with, in most cases, drone types that have a GPS module built in. Okay, so that module also communicates with the flight controller. In addition to that, we've got down here our camera. Okay, and the camera, in most examples, and like what we have in this course, will be attached to something called a gimbal, which I'll explain here momentarily. But you have those also connecting to the flight controller. Then we've got our essentially our propulsion, equipment. So we move over here to our let's see, electronic speed controllers. So another little circuit board which controls the motors, okay, and then propellers. Notice that our propellers there, and this is a quadcopter example, propellers we've got green and green, red and red. So opposite sides, like I was saying, okay? And then the last thing that I've got as an example here is, let's see, can I move this? Yeah. So the last thing I've got as an example is the battery, okay? And some type of battery monitor. And everything that I have in this class, I will be able to kind of break these things down and share with you. Just to give you an example of what we just talked about, let's see if I can do this here. Okay, so let's stop sharing. Okay, so this is my Spark again. Now, I'm not going to take any of these things apart here, but within side of there is our flight controller and our GPS module and our antenna, okay? Our battery actually is hooked up to the back here, and the battery is removable like this, okay? So we have a battery and a drone, okay? Slide that back. Here's my camera, okay? All right. And my, so on the inside of this drone, we've got from the flight controller, then we would go to the motors, okay, and to the propellers, okay. Also, sorry, I meant to say one other thing. The electronic speed controller, there's my finger. Electronic speed controller would be, I don't know if it's actually going to be here or over here, but either way, every single motor would have its own version of that ESC, okay. All right. Now, your gimbal. Let's talk about that. Actually, I did make a mistake here. The gimbal controls the roll. Oops. Pitch and the roll. This one controls the yaw. All right. So what am I talking about? Well, this thing called a gimbal. A gimbal is, let me show you a different drone as an example that you guys are going to get to use. Okay. So we'll talk a lot about cameras in this class, but for now, we're not going to spend a ton of time because we want to talk about everything else but the camera. So first, before I show this drone, let's go over what the heck a gimbal is in the first place. So the gimbal is this thing that actually, that's like, basically it's what the camera is. It goes from the drone to the camera, and it's the middle piece. It's what connects the camera to the drone. So the camera is not just kind of stationarily fixed there with nothing else in between it. The gimbal, what it does is it provides dependable camera stabilization. Okay, without a gimbal, any slight movement, whether it be a push from a gust of wind or quick sticks, trigger sticks, or whatever they are, um, those types of movements will also be seen or will be demonstrated in, let's say, the photography or the video that's being captured in that time period. And also, there's another thing that's not quite as evident, but another part that, um, another thing that suffers is because the drone is, these motors are spinning at thousands of RPM, um, they end up creating a lot of very, very, very minor, okay, not so much that even you could feel them if you touch it, but very minor vibrations. And those vibrations actually bleed into the pictures. And so it's like you have a picture that's got a bunch of like little scars all over it, okay? And so uh, that's what happens. Those examples right there that I just explained, those kind of things will happen if there is no gimbal in between, or no gimbal attaching your camera to your drone, okay? So the dependable camera stabilization is incredibly important when we have the camera attached. And if you're looking into a drone and it doesn't have a gimbal on it, like a starter drone that you're interested in purchasing, I would highly recommend moving on from that, and maybe investing a little bit more money into something that does have a gimbal, because the difference in the video quality will be like standard definition from the 50s to ultra high def in 2020, even if it's the same type of camera, right? And that's how significant of an effect the gimbal actually has. Why is it important, or scientifically, like physically, what's happening here? The gimbal is controlling three things, okay? Potentially three different things. Your yaw, which is the camera. Let's see if I can do this here. The yaw, which would be the camera moving kind of left to right, or like panning, okay? That would be a yaw, okay? The pitch, which would be the camera kind of moving up and down like this, okay? Okay. And then the roll, which would be, well, kind of like what it says. So in more of a, I guess you could say, not diagonal fashion, but the camera is still facing the same exact place, but the actual movement of the housing of the camera is rolling back and forth. Okay, so yaw, pitch, and roll, those are important terms to know for this lecture. With your 2-axis, there's basically two different types of gimbals out there. There's a 2-axis, which would be something like here is on a Spark. So let me do this and show you guys what I mean more specifically, okay? So your 2-axis would control your yaw, okay? Or allow, did I say that right? Back up. My mistake. It will not control your yaw. Because the yaw would be the left-right movement. Okay, start over again. Live TV here, huh? Live TV that you're watching, that's not live. But anyways, so controls the roll and the pitch. Okay. So let's first start with the roll, okay? Here is your roll of your 2-axis gimbal, okay? 2-axis gimbal allows it to roll like this, okay? Pitch allows it to move up and down like this, okay? So that would be 2-axis. I cannot technically move, if I know that it looks like I'm moving it, but I'm moving the camera, but I'm actually moving the entire gimbal, and it won't move. There's a little bit of give in it, just the way the parts are designed. But if I cranked it this way, the thing would break off, okay? So I cannot move it in the yaw direction. Now, on the other hand, my 3-axis gimbal here, by the way, this is called a DJI Phantom, Phantom 4 Pro specifically, okay? And we'll talk a lot more about this in this course. But here we go. Here's a 3-axis. So let's try it again. We have roll. Okay, so here's my roll. Okay, we have my pitch. Okay, there's my pitch. And here's my yaw. So roll, pitch, and yaw. Now, I'm gonna turn this on in a second and I'll show you guys what this technically looks like, because it's pretty neat when it's all going and powered up. I will be right back. Okay, so here we are now. The Phantom is turned on. Notice by the little bit of the humming sound and the lights that are flashing. Okay, as we look at this Phantom here, the red lights that you're kind of in the front of me, that would be considered the front of the drone. Okay, so as the drone flies this way, notice it's also where the camera is pointed. That would be considered the front of the drone. The two red lights will always stay like that. Now in the back, we've got a couple of green blinking lights, and the green lights indicate not only the back, but the green itself indicates that there is the drone is searching for a GPS signal. Okay, so it has a GPS module, but because I'm inside, the satellites are blocked. So it's searching for them right now. I can still fly, but I won't have the assistance from the GPS itself to kind of stabilize the actual flight itself, which I'll talk about here momentarily. What I wanted to share with you guys was the gimbal in action. So pay attention to right here. Okay, let me try to get this as stable as possible. But pay attention to my camera here. Even as I move it like this, so the drone is moving, but look at the camera. The camera the pitch is actually being stabilized in real time. Even though the drone is moving, the camera is staying in the exact same place. So there's my pitch, okay? Now here's my roll. Notice that the camera, again, is staying in the same place. There's the roll, okay? And now here's my yaw. I mean, I can only go so far, but they're so many degrees left to right. But notice that the gimbal is trying to correct itself, correct the camera as much as possible, okay? All right, there's my 3-axis gimbal explanation. Put this over here now. And I'm actually gonna power that off because it might start beeping. All right, so moving on to the next slide. Perfect timing. Let's talk about the remote control and the monitoring device, okay? Well, actually, I'll just power these back on because it makes sense for what I'm about to share with you guys. Okay. So I left my drone just stuck down there on the floor next to me. And let me walk through some of these examples and then I'll show you again in real time. We've got 2 different frequencies that most of these remote controllers can work from. And in the case of the DJI products, they are actually dual frequency, so it'll select between the 2 for which is the best for the particular range you're flying, between the 2.4 and the 5.3. The Phantom 4 that I have as this example, range-wise, okay, so how far away it can fly from you as they advertise it, 4 miles, right? So 4 miles. Now, that's pretty far. That's pretty good distance away. I've never taken one further than about 1.5 miles for a couple of reasons. Number one, I don't think the batteries could last that long, at least going coming back to me. It's one thing to go all the way there. You got to consider if you make it all the way to the end that you want, you better have more than 50% because you're going to have to come all the way back. Number two is, as I'll explain here in a minute, the feed between the camera and the camera and the drone, right? In the monitor, it starts to fade out a little bit. The further out, the further away you go. Nevertheless, a mile and a half is still really far. Oh, there was a third example, line of sight, something called line of sight. Line of sight meaning physically here, right, with my eyes, if I look up into the sky, I can still see the drone itself flying somewhere, right? And it might be a little tiny, tiny speck, but as long as I can see that speck, I still have line of sight. Now, if I can't see that speck, and I know it's flying because I see on my monitor that everything's working, I'm actually breaking a rule. So even from that perspective, flying 4 miles away with something that's only this big, you're going to lose it in the air, okay? And there's also a line of sight rule from the FAA that we'll learn about. But yeah, let's just go over some of the highlights. Continuing on, we've got an HD live video feed, and you are looking, so it's like you're always looking at the camera's view, okay? The camera or this video feed is going to be on some kind of screen, and the screen, there's two different examples. It could be either the screen is built into the controller itself, or that it's provided. You know, it's an iPad or phone or something like that that you provide it yourself. So here's the examples I have. So let's see. Oh, all right. Dedicated flight controller app, and then dual RC, one for flying, one for camera control. Let's break this down, show you here just like as if we were in person. Okay, so here's my, whoops, yikes, don't want that to happen. Tighten this up a little bit. Okay, so here's my example of my remote controller here, okay, with the manual sticks that we would use to fly the drone, and you guys will get practice with these. On the back side, yikes. On the back side, I have my little places where my wires connect, but I also have these antennas here, okay? So these antennas are what communicate outwards to the drone itself and to the receiver on the drone, okay? And then if I turn back this way, let's go ahead and power this on. I also have an iPad, you couldn't tell. This is just my iPad connected to the, via the iPhone wire, connected to the controller. So I can power this on here. Whoops. 1, 2, like that. Boom. There it is. So once I've got the little lights here and a green light showing me got power, I am now able to control my drone. And here is the live controller or camera view of my drone. Okay, so let's see if this works in real time. It's a little finicky. This controller's been around for a little bit as the screen keeps wanting to fall forward, but that's okay. Let's see. If I do this, see if we can get a picture of ourselves. Uh-oh, what happened? Aircraft disconnected. That's strange. Let's try again. Doing this kind of thing indoors, you certainly run into more things, challenges come your way, or little occurrences that if they happened in the field, you'd say, oh, this is not good. But knowing that I'm indoors, I'm not too worried about some of these odd things that are occurring. Okay, so now I've got, bear with me everybody, try to show you this. Okay, here's my screen, okay? And here's my drone. So I've got, let me back up. We've got drone and, oops, let's do it like this. Drone and screen. Okay. So that's a picture of the computer I'm using. And that's a picture of my wall. Okay, now if I move, check this out, testing the gimbal. Look at me move the drone around. Notice my screen, the camera view on the screen. It's hardly changing at all. So now you have an example of my gimbal in real time as if the drone was flying in all these various positions. And the screen itself is staying pretty stable, all things considered. Okay. I did have a bullet point on the slide about how to what am I using to pull up this screen. It's just an app. So it's down here. It's called DJI Go 4. Okay, but there's actually well, DJI is the make. So just to control it, it's best to use for like general flying. It's best to use the app that the manufacturer produces. For other purposes like mapping and doing surveying work, like we're going to do in part 2, there are third-party apps that we can use to actually fly the drone as well. Okay. I'm sure for filming and some of the things that Kennedy might have suggested, apps-wise, we'll explore those too. All right. So that's kind of the makeup of it. I mean, I know doing this virtually, you're not really getting the same feel of it, but we will. When we get in the field, you'll be able to touch this stuff. You'll be like, oh wow, okay, now I'm seeing as the drone is flying away, and I've got this beautiful HD picture in front of me. I'm seeing everything that Professor's talking about. Let's talk about batteries. I have a couple more slides and then we're done. So here's the battery on the back of the drone, okay? This is a lithium polymer or LiPo battery, okay? This being a consumer drone, well, not all consumer drones, I should say, have smart batteries, but most do. In particular, all of the DJI types of models have these things called smart batteries. And what's great about the smart batteries is they balance the cells themselves, meaning that, well, it's just a lot less maintenance from the user side. Basically, I plug it in and go. And if I'm not using it for a while, I can put it in the plug into what's called the storage mode. And from there, it'll just control itself, okay? So it won't discharge over time or something like that. The thing with LiPo batteries, however, I'm gonna turn this off for a second. Power off is always, with DJI stuff, one click and then a click and a hold. No more power. The thing with DJI, or the thing with LiPo batteries, especially in the beginning, was they were very suspect to fires, kind of combustion out of nowhere. So, because of that reason, when it comes to commercial flights, you can take your drone with you, but you have to take the batteries out and you have to carry them on. In the event of there is some type of fire in the cabin, it can be put out quickly. But I'm not going to spend a ton of time on batteries. It's pretty straightforward in terms of the smart batteries that we use in this course. Yeah, we just put them in storage mode when we're not using them and keep them there like that. As far as I know, they have a lifespan of at least, I'm talking about experience from me having the same battery for the last 5 years or so. They will be able to go about that range, but it also depends on how many uses, you get out of it. If you're flying every single day and you end up with 1,000 uses over, say, a period of 3 years, probably burn that battery out, as opposed to the person that's flown it only 100 times over 3 years. They've still got some time left. Okay. I think that's about it, honestly, for batteries. Okay. I do want to also talk about this thing called sense and avoid sensors. Okay, whatever drone you end up looking for or are interested in, pay attention to all these little nuances. The more expensive they are, it's probably related to something like payload capacity, but it could also be onboard sensors that you may or may not be interested in. Oh, one last thing about batteries. People always want to know, how long do they last? The Phantom can fly for about 20 minutes on one battery. So, FYI. And most copters are in that range of about 10 to 25. I've seen a different make fly for about 25 minutes. That's about the longest I've seen when it comes to copters. Okay, so additional sensors like sense and avoid, that would be on this Phantom. Notice here, so there's a couple, there are some tiny stereo cameras, sonar sensors. This one doesn't have a LiDAR sensor for laser ranging, but some do, okay? Essentially, they all kind of do the same thing, which is called sense and avoid. All right, so like, for example, if the drone was flying backwards like this, I know I'm coming towards you, and I have my sense and avoid feature turned on. As soon as I got within, let's actually do it like this. As soon as I got within 5 feet of this object, the drone's gonna stop like this, and it's gonna beep, and it's gonna tell you, you can't fly into this object because you will crash, okay? So that would be the case in the back, on the side, on this side, in the front, okay? As well as on this side. So 4 sides horizontally. Now on the bottom, there are these little sonar sensors, okay? And also the stereo cameras as well, okay? And what these help do is when you're coming down to land, okay, so like this, what they end up doing is they help, well, let me put it this way. The majority of drone crashes occur during landing. It's not during flying, and it's not during takeoff. It's when a person's coming down and landing. It can be a very jolting experience, okay? So what happens is, if you've got full throttle and you come down, say, 20 miles an hour straight down, you're probably gonna break something. These sensors here help identify where the ground is, and they kind of slow the drone down. So if you're coming down, slows it down, brings it down to a slow stop. Okay, that's what they're there for. It's pretty amazing. The technology built into these machines, because it's almost foolproof in a sense, right? And I've taught this class a few times before. Knock on wood, I haven't had somebody actually crash one of these drones yet. Okay, in some part due to the sense and avoid sensors that are built into the systems, but also just due to overall, and now my controller's beeping. Overall safety precautions that we take. Anyways, it's good to have that kind of safety net in this with those sense and avoid sensors anyways. Okay, guys. So I know this lecture is kind of getting long in the tooth. Let's move on to my last slide. I want to mention some considerations, okay? Because this lecture is all about, now we move on to the equipment side. Just things to consider and think about, okay? This is electronic technology, and there could be failures that occur. It's just part of having this type of technology at your disposal. The GPS itself, right? It's never going to be completely 100% foolproof. Say if there's a loss in satellites, right? Now, sufficient satellites for the drone to have what's called a GPS lock onto it, which will provide assistance as you're flying along. In order for that to occur, the drone needs to have between at least 6 to 8 satellites connected to it. Ideally, it's going to connect to almost 20, but it needs at a minimum that amount, okay? If the GPS drops, it causes the controller or the controls to be very challenging. Think of it like this. It's like if you've ever driven a car, and I don't know how many of you actually would know this example, but if you've ever driven a car that does not have power steering, it's almost like, you know, it's like you're trying to drive a giant tractor trailer or something. Even if it's like a small little Toyota, it's a very difficult thing compared to, you know, 99.9% of the cars that actually have power steering out there. But it's basically what it does. The GPS assistance, you don't think about it because it's so common as a built-in technology. Again, we're talking consumer drones. Most toy drones, as I mentioned, most toy drones do not have the GPS assistance built in. And you'll notice the difference, right? But anyways, yeah, if the GPS drops out, that will cause challenges. Another thing to consider is the compass, okay? The drones do have compasses on board. The drones do have compasses on board, and if they come in contact with large metal objects or, you know, large structures like, you know, big metal buildings, this can cause some serious malfunctions, because if the compass breaks down mid-flight, this could be a serious problem. Now, again, here we are with this foolproof type drone stuff. If we were talking 5 years ago, this would be something that I would say we're going to run into this problem whether we like it or not. Because I've had many drones crash in my early days over these kind of simple things. But now, in particular with the DJI drones and some of the newer makes that are coming out and continue to evolve, the DJI stuff has what's called dual sensor redundancy, which means that if part of it breaks down, it's still got a backup there, right? So you're much less likely to experience interference. If there is an interference and we have this backup that kicks in, you'll get a notification on the controller, on the screen, and it'll say, hey, come back, recalibrate all your sensors, recalibrate your compass, and then that will fix everything, okay? Again, here's the thing. I have yet to have a DJI drone, other than this, you know, recalibration warning come up. I've yet to have one completely fail me in real time. So that's actually a good thing, okay? And then we did mention this a little bit, but I do want to kind of end with the line of sight discussion. Yeah, the further away you are, the more likely the radio control is to drop out, okay? I know that it's advertised at 4 miles. I wouldn't even trust it to go half of that, just for my own sake. Because like I said, that line of sight, and you'll see, it's very, very difficult to pinpoint once you get out past a mile or so, right? Think about the Spark, how little this thing is, right? This is about 6 inches, 7 inches tall. Imagine something 7 inches tall, and also in this horizontal direction, over a mile away. Can you pinpoint something that's over a mile away, that's only 7 inches wide or tall? Think about that, okay? It's also very hard to control the drone manually if it's out of sight, right? So things that I want you to consider, okay? That's gonna do it. So let's go ahead and wrap up. Okay, that's going to be your first lecture for this course, all about history, uses, and equipment. I hope you found this to be useful and educational, and make sure, well, if you got to this point, you've watched the whole thing. So good for you for making it this far. Get onto that first quiz, work on that, and look for additional things to come your way from me as we go through the course. All right. Thanks so much, everybody, and have a good day. Bye for now.